In the previous video, we looked at adding code modules to a package. In this video, we're going to take a look at how to make those code modules interact with each other within the package. We'll start off by understanding the difference between absolute and relative imports, then moving on to writing those, and finally, we'll look at cyclic dependencies. When we're importing one of a package's modules from outside the package, there's only one sensible way that it could work. We tell Python which package and module we want, and it either finds and imports it or raises an exception if it can't. Simple. When we're already inside a package, the situation is more ambiguous because import name could just as easily mean look for name within this package, or look for name in the Python search path. Python breaks this ambiguity by defining import name to mean that a package or module called name should be searched for in Python search path, and by giving us a way to specify a relative import if we'd rather have it just look within the current package. We could specify a relative import by putting a dot in front of the name of the module we want to import. When Python sees that, it will look for a module called name in the same package as the module our code is running in. Often, we only need one or two objects from another module, and it's more convenient to import those objects directly into our global scope than it would be to import the module as a whole and access its contents. Python lets us do that with a slight variation on the import syntax. Finally, sometimes we want to rename an object within our scope as we import it. We can do that by modifying our import with the keyword as. In this example, even though the object is called foo in the name module, in our current module it's named bar. This trick works for absolute imports too, by the way. Before we move on, let's take note that Python 2 used a different rule for deciding where to find imported code. In Python 2, it first tried to find the target of an import within the current package. Then, if no matching module was found there, it went out and looked for it on the search path. That approach usually did the right thing, but occasionally caused problems due to the ambiguous meaning, and it meant that we couldn't have subpackages, or modules that shared the name of anything in the standard library or other installed packages. So, this behavior was changed in Python 3. There's something that might trip us up when we're importing a module that shares the same package. Sometimes the module we're importing wants to import us as well. This is called a cyclic dependency. When we try to import a cyclic dependency, we'll almost always get an attribute error exception. As in this example, that happens because when we ask Python to import the first module, Python immediately creates a module object for it and begins executing the code in the module. That's fine, except that when Python gets to the import statement for the next module in the cycle, it pauses running the code in the first module, leaving it not fully initialized. Even that isn't normally a problem because Python will come back and finish the initialization later. However, when the second module asks to import the first module, Python just hands it the already allocated and not fully initialized module object. When the second module tries to access the variables stored in the first object, many of them will not yet have been created. Hence, an attribute error is raised. There are two common ways to address this problem. The first, and usually the best, is to break the cycle by taking some of the code from one of the modules and moving it into a third module, which both other modules can import without causing a cycle. In this example, if we move the A class into its own module, there would be no cycle, and all would be well. The other way to address this problem is to move the import statement that causes the cycle. If we move the import statement down until it's below all the variable definitions that are needed by the other modules in the cycle, the module will be initialized enough when it's imported by the other modules. Python will still come back and finish the initialization later. In this video, we've gotten a pretty good handle on how to import modules into other modules contained in the same package. In the next video, we'll move on to adding static data file resources